What's up, guys? It's your boy Alex here, coming back with you another video. Today we're going to be talking about big O notation. So big O notation is a way for you to measure how fast your algorithm or code is going to be running. Um, so what is big O notation? So normally it's represented in something like this, O and then parentheses n. It kind of looks like a function call. So what is O? O is a coefficient. So if you think of something like the y equals ax plus b equation, the equation for a line, here the coefficient for x is a. So you can think of O being analogous to a and n being analogous to x. See, they mean different things, but they're coefficients and they just get multiplied together. So let's measure the runtime of one of some code. So first, let's say we have a list, and let's just say it has 4 elements, and we just want to go through the list and print out every element. Pretty simple code. So how many operations is this going to take? For now, just to not confuse anyone or anything, let's just look inside of the for loop, because that's where the majority of the runtime is going to be. You're going to find that's a common thing in big O notation, because just with like loops in general, that's normally where most of the code running is going to happen, or like recursive calls, but that's more confusing. So we're going to stick to loops. So in this loop, it's going to run 4 times. Specifically though, the print is going to run 4 times. So that means essentially it's going to be running the length of the list, right? In this case, that's 4. But we need to consider what happens if the list is of arbitrary length. So what happens if this list goes on until, like, let's say n, right? So since it touches each element in the list once, we can say that there's n operations, or we can say that this algorithm is O of n. Now you might be wondering what happens if there's more lines of code. Let's say we wanted to print not only x, but also, let's just say, x plus 1. So now there's 2 lines of code, and instead of n, you might be thinking, oh, there's two times as many lines of code being run. But remember, since O is just a coefficient, and since 2 is also just a constant, the 2 can get absorbed into the O, and it's still O of n, even though it's technically twice as many lines of code running. In fact, we can do something a little redundant and say, like, for x in list, print x again. And you can see that this loop runs n times, this loop runs n times. So together they'll run a total of 2 n times. And that brings us back to this, in which case we know that the 2 will just get reabsorbed, and it's just O of n. And actually, if you keep adding separate loops like this, it will still always be O of n, even though you're kind of increasing the amount of lines of code being run linearly. So let's take a different problem then. So let's say instead of just printing out x, we want to generate all the pairs in the list. So that's going to be like 1, 1. It's going to be like 1, 2. It's going to be like 1, 3, etc. Right? So to do that, we can do something like for y in list, and then print x comma y. So for this, we'll notice that we do have 2 loops again, but we need to calculate how many times they run. So let's just consider our basic case again. So what it's going to do is go through the 1, and then it's going to go to the inner loop, and the inner loop is going to go through the loop. So that's going to be 1, and then it's going to touch 1. So 1, 1. Then it's 1, it's going to touch 2, 1, 2. 1 is going to touch 3, 1, 3. 1, 4. Then it's going to go back to the outer loop. It's going to go 2, 1, 2, 2, 2, 3, 2, 4. So in total, we're going to have 4 by 4, which is 16, and we're going to generate 16 pairs. Again, though, we need to consider arbitrary length lists. So we can easily calculate that this would actually be n times n operations. So here we do have a difference in the runtime when compared to the original list. So instead of n, it's actually going to be n squared, because n times n operations is going to be n squared. And that's kind of in line with what our example list, because we're going to run 16 lines of code, and that's 4 times 4, or n squared. And same rules apply here. Like if we added another another print statement here, it would be like 2 times n squared, and again the 2 gets absorbed into the O. Also, if we added more linear loops, or I guess non-nested loops, it would still be O of n squared. However, if we continue to nest loops, like let's say we did for z in list, and we had something running, in that case, it would go up to n cubed. And the more kind of nested loops you do in this fashion, the more the the more the exponent or the power of the runtime is going to go up. So we've considered going up. Now, what about going down? So let's say our problem now is that we just want to cut the length of the list in half until there's only one element left. So let's say let's have an output list, and initialize it to list, and we'll say while the length of out is greater than 1, we're going to continue to loop, and let's just say out is equal to out of half of its length. So what this is going to do is, let's look at our original list here. We have 1, 2, 3, 4, and then on the first iteration, it says, okay, the length of this is too long, so we're going to cut it in half. So it's going to go to, actually, I think this should be something like this. So it's going to cut it in half, and then it's going to make an array that's half the size, and then it's going to do this. So this actually runs only 2 times, because like initially we have this, and after the first iteration we have this, after the second iteration we have this, and then we're done. So for a list of length 4, we had it run 2 times. And then you can imagine, like, if this list was maybe twice as long, it would actually only run 3 times, because we cut the list in half. So let's just take a look at that. 1, 2, 3, 4, 1, 2, and 1. And remember, this first line is the initialization, so it doesn't count for like a line of code being run. So here we have it running 3 times. You can imagine if we keep increasing by factors of 2, we're gonna only be increasing the amount of times it runs, like by 1 for every factor of 2. So for this kind of algorithm, it would be, instead of O of n, it's actually O of log n. And that kind of makes sense, because if we look at the length of the list, and it's n, and we take the log base 2 of the list, we say like log base 2 of 4 is just 2, and then log base 2 of 8 is just 3, and that's in line with what we've been doing. But it might be confusing why we're saying log here instead of log 2. Well, that's because like logs can be rewritten based on you can rewrite a log space based on just some math tricks that maybe you've learned in algebra. And this is useful for calculating, like runtimes or something like binary sort or anything of that fashion. And once again, all the same rules apply. If we did something like print statement here, it would just be 2 times it, and then the 2 would get absorbed. Alright, so that's my little crash course in Big O notation. Hope you enjoyed. Make sure to like, comment, and subscribe, and see you next time.